The last part of 1.3, or the last part of the problems from 1.3, are these the problems that are in this category of geometry formulas. Now, there's tons and tons of geometry formulas out there. So let me just focus on three formulas that you'll see in this class. Okay. First off is a perimeter of a rectangle. So perimeter of a rectangle is twice the length plus twice the width. Hopefully we know length and width of a rectangle. Another formula that you'll see is the area of a rectangle. Area of a rectangle is the length times the width. All right, so those two formulas apply to rectangles. Now, the third formula that we're going to see in these categories is a formula that has to do with the angles in a triangle. It turns out the three angles of a triangle, I'll call them lowercase a plus b plus c. The three angles of a triangle have to add up to 180 degrees. All right. So again, these are geometry formulas. You've probably seen these before at some point in your mathematics education, but these are the three that we're going to focus on in this class. Now, by the way, looks very similar to a related sums type problem. You look at this perimeter, we just have a perimeter which is 2L plus 2W. We have angles of a triangle adding up to 180. Notice this looks very, very similar to the consecutive integers problem. This looks very similar to the related sums type problems here. Area is a little bit different, but we're just going to use area as solving things. So it's mostly perimeter of a rectangle and angles of a triangle type problems. So these can be demonstrated in questions 19 and 20 of the instructor-led problems. Those are on page 39 of the workbook. So on problem number 19, it says the perimeter of a rectangular garden is 60 yards. The width of the garden is 3 yards less than twice the length. Find the length and width, and then what's the area of the garden? So, first sentence here tells us which formula we're using. Perimeter of a rectangle. Perimeter of a rectangle is 60 yards. So what I'm going to do is I'm going to go to the perimeter formula. Perimeter of a rectangle. And I'm going to say, well, if the perimeter is 60 yards, then I can input a 60 in for that P. Now, the next sentence in the problem relates the length to the width. It says the width of the garden is 3 yards less than twice the length. So the width is, and then it tells you that in terms of length. So here's what we do. In the same way we dealt with the related sums, I'm going to say 2L plus, plus 2W, but I'm going to put a parentheses around W because I am going to replace that W with an expression which comes out of that sentence. Specifically, the width is 3 yards less than twice the length. So the width, W, I can replace with twice the length minus 3. So 3 yards less, that's a minus 3. Twice means multiply by 2. So 3 yards less than twice the length is 2L minus 3. Hopefully that makes sense. 3 yards less, that's a -3. Twice the length, that's times 2. And at this point, this is a linear equation in one variable. So I can go ahead and solve it. Again, if I ask you to write an equation, I'm looking for this one. So 60 is equal to, well, this one causes me to take 2L plus, causes me to distribute, so 2 times 2L, that's going to be 4L. 2 times -6, that's or -3 is a -6, excuse me. Combine like terms, 60 equals 6L minus 6. And then I do my normal getting all the constant terms over to one side. So we're going to add 6 to both sides. 66 equals 6L. Then divide by that coefficient of L, divide by 6. You get 11 is equal to L. All right. So once I combine like terms, add 6 to both sides, divide by 6, you get length is equal to 11. Now, remember, if the length was equal to 11, the width has to be 2L minus 3. So if you take 2 times 11 minus 3, you come up with a 19. So it's here, length is 11. This would be in yards. Everything's in yards or square yards here. Width is 19 yards. Okay? So that's the idea. By the way, you can double check that when you put it into this formula, if you take 2 times 11 plus 2 times 19, you should end up with a 60. And sure enough, you do. Now we've almost solved the problem. I say almost because we did find the length and width of the garden, but this one also asks what is the area of the garden. So this one at the very end kind of throws in an area question. And we know that the area of a garden, of a rectangle, I should say, since area of a rectangle is length times width. So all we need to do is take 11 times 19 and end up with 209. So the area is 209. By the way, this would be square yards because area is in squared units. Some people will write YD with an exponent of 2 as shorthand. All right, so that's the idea of how to use a geometry formula with solving a linear equation. It's very, very similar, as you can see, to the related sums. There's a relationship between, in this case, the L and the W, and that's what happens. All right, so let's take a look at the next one. The next one here is number 20, and it says, in a triangle, the second angle measures 4 times the first. The measure of the third angle is 18 more than the second. Find the measures of the 3 angles. So we have 3 angles of a triangle. We know the formula for that. The formula for 3 angles of a triangle is that the 3 angles of a triangle, which we called A plus B plus C, have to add up to 180 degrees. By the way, if you want to put that little 0 here as the exponent, you can do that. I shouldn't say 0. It's not a 0. It's a degree mark. You can do that as well if you'd like. All right. Now there's going to be a relationship from A to B to C. And we have to figure out the relationship between A and B and C. That relationship is going to be in the next two sentences. All right, so the second angle measures 4 times the first. Let's call our first angle the A and the second angle the B. So if the second angle measures 4 times the first, 4 times the first means that B can be replaced with 4 times A. 4 times the amount of A. Now let's look at the third angle. The measure of the third angle is 18 degrees more than the second. Now be careful here because it's 18 degrees more than the second, not 18 degrees more than the first, 18 degrees more than the second. So if I'm looking at the second angle here, that's 4A, 18 degrees more than the second is 4A plus 18. All right, again, this is the second angle. We want to go 18 degrees more than that. And now we have an equation. Okay, so if I ask you to come up with an equation, this is the one you'd be doing, you'd be creating. And now we can solve this for A. So A plus 4A plus 4A, that's 9A, plus the only constant on the left-hand side is 18. So we got 9A plus 18 is equal to 180. Obviously, we'd take 180 and subtract 18 from both sides. So we get 9A on the left-hand side, and on the right-hand side, I get 162. Lastly, I divide both sides by 9, and I come up with A is equal to 18. Now remember, A was my first angle. The question asks me, what are the measurements of all three angles? So I need to figure out what B and C are as well. But that's nice because I know B is 4 times A and C is 4A plus 18. So I can just say, well, if A, whoops, excuse me, if A is equal to 18, B is equal to 4 times 18. So I just take 4 times 18. You know what? I'll just write 72 there because that's 4 times 18, obviously. And then C is 4 times A plus 18. And if you do the math on that, that becomes 90. So the angles are 18 degrees, 72 degrees, and 90 degrees. Okay, and again, if you want to put that little degree mark on these, go ahead and do that. There you go. I've tried to do that as best as Microsoft can. So there we go. 18 degrees, 72 degrees, and 90 degrees. By the way, on this one, I'm not going to care if you leave off the labels or anything like that. On the degree marks, you should know that length and width are both in yards if the perimeter is in yards, or length and width are both in feet if the perimeter is in feet. So be able to label those things. Again, I'm not going to worry too much about the degree little symbols, but there you go. So those are the types of problems that we're going to do in 1-3. As you can see, they're pretty varied. We have percentage type problems. Always can break them down as end equals rate times original. You have the related sums type problems, and then you also have these geometry formula type problems. All right, so that is it for section 1-3.